want to analyze OJ electron emission. Okay, so do not the atom are not intelligent. So they don't decide what to emit. So when they absorb a photon, physics will occur, right? So emission of photon and emission of electron, photoelectron will occur, okay? And of course, we try to learn about what is the probability of this emission. So this is why people invented all this term, cross-section. So electron emission, photoelectron emission, and X-ray emission have a cross-section. And this cross-section means that correspond to probability of emitting a photoelectron or probability of emitting a photon. So we characterize how strong an emission that will occur. They will occur. It's just a question of how much, and it's material dependent. This cross-section, of course, gives you the intensity, because that related, if you have a higher probability of emitting, you can detect them, then you can see higher intensity. Okay?
So every material exhibits this phenomena?
Every material, because every material have an electronic structure, and you excite the material, and the decay is the same. There are two ways to decay, either by OJ electron emission or photon emission, and they will occur. And so don't think that we can turn off the other. We can't. We just use different tools to examine different part of the emission, either OJ emission or X-ray emission. We build different tools to look at that. Okay, so that's a good question, because some people get confused. Okay, why can't I just detect X-ray? They are there, because we just don't have the tool in that machine to detect the emission. That's all. Okay, and finally, the other topic that we are planning to talk about is, of course, chemistry. So there are surface reaction and kinetics, and we have a lot of stimulated desorption technique. We have either desorption of material after you have an electron absorption, or stimulated by electron, or you can stimulate it by a photon. So we have different type of stimulated desorption techniques. So this is electron stimulated desorption. I will skip this for now because I'm running a little bit, spend too much time on this. Except I'll come back to this later when we are talking about it. It's electronic excitation of your material. If you have enough kinetic energy to the electron, the material can come off from the surface. And so this is a spectrometer that detects this material that come off, and you detect it by measuring the ion that come off. I'll come back to this. And of course, you can do the same by stimulated by electron or stimulated by photon, right? So you have photon stimulated desorption or electron stimulated desorption. And of course, the easiest way to dissolve something is what we do. You just heat it up. You have thermal desorption. So here's some data that collected by us some years ago on pyridine. Pyridine on silicon surface, on different silicon surface, amorphous silicon, oxidized silicon, or hydrogen terminated silicon. And you basically just heat it up as a function of temperature here. And then you detect the fragment that come off, and then you use a mass spec to identify them. So you have different fragments. You can see different fragments that come off. So pyridine is an atom, is a molecule that looks like this. It's a 6-membrane with a nitrogen like this. This is deuterated pyridine. So you replace the hydrogen with deuterated atom. So you can look at this fragment and analyze how the material absorb, and maybe come up with some reaction mechanism pathway to draw some conclusion about your absorption and the strength of the absorption that you got. So this is thermal desorption technique. And it's quite easy to do, relatively easy to do on this. Okay, so let me move on quickly. Before I do that, I want to remind people those who are in the course to work on this term test, not term test, the term paper thing. Let me bring up the slide. We're still at the end of the month, so 2010. Okay, so again, this is 200 word. I want people to start thinking about the little